Now that we have derived the first and the second equations, let us see how to derive the third equation, v square equal to u square plus 2as, which shows the relation between velocity and distance. So before we see how to derive at the third equation, let us look at how to calculate the area of a trapezium. If you see at the left hand side, there is a trapezium, and if you see, A and B are the parallel sides and h is the distance between the parallel sides. So area of a trapezium can be calculated using the formula half into sum of the parallel sides into distance between the parallel sides. So half into h into a plus b. So coming to our old figure here, through which we are going to derive the third equation. So if you see here, we also have a trapezium here, O, A, B and C. So if you see this figure, the parallel sides are of this trapezium are OA and BC, and the distance between these parallel sides are AD. So remember this. The parallel sides are AO, which is parallel to BC. Okay, AO and BC. These are the parallel sides of the trapezium OA, B and C. And the distance is AD between the parallel sides. So if you see, look at this figure, then the area of this trapezium will be half into height or the distance, which is AD, into sum of parallel sides, which is AO plus BC. Remember this formula. So in the previous derivation, we had actually calculated the area of the triangle and area of rectangle, added both to find the distance travelled. Here in this case, we are going to find the distance travelled by S equal to the complete area of the trapezium O, A, B and C. And as I told you earlier, the formula is S equal to half into sum of the parallel sides, which is OA plus CB, into distance between the parallel sides, which is OC. So when we are substituting the values, we get OA is equal to U, or the initial velocity, CB is equal to V, or the final velocity, and OC equal to T, the time. So S equal to half into U plus V into T. Now if you try to recollect the equation here, see the third equation here, there is nowhere the presence of time or the quantity T. So we have to eliminate T and substitute it with other values. So come back to this equation. So here we have S equal to half into U plus V into T. Now using the first equation of motion, which is V equal to U plus AT, we are going to find T. So T will be So from this we know that AT equal to V minus U. So T will be equal to V minus U by A. So here instead of T, we are going to substitute this value V minus U by A. So we will get, you can see the next step here, S is equal to half into U plus V and instead of t we are writing v minus u by a. So try to calculate this and finally you will be getting the third equation, which is v square minus u square is equal to 2as, or you can write it as v square is equal to u square plus 2as, and this is the third equation of motion. I hope all the three derivations were clear to you. So the first, we are using the same figure for all the three derivations. In the first derivation, v is equal to u plus at, we calculated the acceleration with the slope, and for the second derivation, s is equal to ut plus half at square, we calculated the area of the triangle and the area of the rectangle. And for this third derivation, v square minus u square is equal to 2as, we are calculating the area of the trapezium. So while looking at it, you might feel it quite simple, but I want you to go through all the three derivations and close the book and then draw the figure and try to derive it without seeing. Keep on trying it. In case you have any clarifications, let me know. Until then, bye.